Going to assume that you all are comfortable with object-oriented programming? Yes. So let's take an example. There are no PPTs and that's good. So I'll bank on your visualization. And that's the best thing. It's always so handy. Let's assume that you are using a library, object-oriented library, class library, and there is a class in it called Tiger. So there is a Tiger class. Okay, I thought I usually use the name C1, C2, but I thought now Varad is also here. The Tiger class which has a function called M1, and I want to use it. What's the big deal? There is a class called Tiger and I want to use a function M1 of that class. Fine. Create an object and make a call. Yes, it can be done. But who is calling it? Lion. So there is another class which is Lion class. Yeah, so what should Lion do? Create an instance of Tiger class and make a call. But Lion has a problem. He says, I will not call M1. I don't like M1. I will call N1. So class Lion wants to call N1. Tiger is providing M1. And you have to solve the problem. So you'll have to call the fox. Let the fox come afterwards. But the problem is, two classes are there. One class is having method M1. Another class wants that service. But it says, I will not call M1. I just will call N1. Now what is the solution? One simple solution is remove the problem. Compromise. Negotiate. Both are in binary. You don't have the source code. What will you do? You will modify the code if you have the source code, right? Oh, that means these are the two libraries who want to talk to each other. So you don't have the source code of Tiger, you don't have source, don't do decompilation, huh? No, sorry. That is the constraint. How will you do it? Well, most of you already know the answer. What we'll need is one more class. Let Mr. Lion call that class. Let that class have a method N1 and that class will internally call M1. Simple. We can elaborate on this, but I have not given you code and you can't see code, so I'll keep my statement simple. Now this fox who is in between, you know what is this? It's a non-intrusive design. What is a non-intrusive design? A design element when you put in the original solution without affecting any component of the original solution. We have not changed the tiger, we have not changed the lion, and we have made them talk to each other without affecting them. This is a non-intrusive solution.
Many of you who have done RMI or Korba, they know that whole layer is non-intrusive layer. Everything else remains the same. Anyway, this Mr. Fox is solving a problem. What problem it is solving? Let's stick to it. Name, solution, problem and context.
Keep on mapping. The problem is interface mismatch. The client, that is the code which wants the service, is expecting a particular interface, and the server who is providing the service is having a different interface. So this is a typical problem of interface mismatch. Can be solved by bringing one more class in between who will solve the problem of this impedance mismatch, the interface mismatch. Such a solution, such a class is called adapter. So this is the solution, and then this is a pattern. This is adapter pattern. So the problem, interface mismatch. The solution, adapter pattern. What is the consequence? Constraints were non-intrusiveness of the solution was the constraint. Otherwise we would have modified the two class and the whole thing would have got over. Consequence is, whenever you want to make a call, actually you are making two calls. Okay, let's stop here. I have just shown you one consequence. We can go further. But this is adapter pattern.